Scientific notation. Scientific notation is a way to record numbers. Why do scientists need scientific notation? Scientists regularly deal with very large or small numbers. Scientific notation lets them record and communicate these numbers very easily. Pause the video to write down these notes. Now let's take a look at what scientific notation looks like down here. Scientific notation will be some number multiplied by 10 to the power of something. Now we multiply by powers of 10 because multiplying by powers of 10 will allow us to move our decimal point over to the left or to the right to get bigger or smaller numbers. Now this number in the front must be greater than 1 and less than 10. So it's only going to have one digit in front of the decimal. Our exponent will tell us if we're dealing with a very large number or a small number. Now, if we have a positive exponent, the number is going to be greater than 1. If we have a negative exponent, our final number will be a number less than 1. So a negative exponent will tell us that we have a very small number. A positive exponent will tell us that we're dealing with a large number. Go ahead and pause the video to write down your notes. Now let's go over the process of converting numbers to scientific notation. To convert a number to scientific notation, position a decimal point so that there is one non-zero digit to the left of the decimal point. Then you count how many places you move the decimal point to the right or to the left. This will be the exponent of 10. If the original number was less than 1, then the exponent will be negative. If the original number was greater than 1, then the exponent will be positive. Let's give it a try. Convert 345,000 to scientific notation. First, I notice that I have a number greater than 1. This means I will have a positive exponent. First, I'm going to write in my decimal point in the correct position. Next, I have to determine how many places do I need to move my decimal point in order to have only one non-zero digit to the left of the decimal point. So now I'm going to count how many times I have to move it. 1, 2, 3, 4, 5. I have to move my decimal point over to the left 5 times to have one non-zero digit to the left of the decimal point. Next, I will rewrite my number. I have 3 45 times 10 to the power of 5 because I had to move my decimal point 5 times to the left. Let's try the next example. If you would like to try the next example out on your own, go ahead and pause the video and try it out. Here, I have a number less than 1. That means I need a negative exponent. Next, I write down my number and determine how many times do I need to move my decimal to the right in order to have only one non-zero digit to the left of my decimal point. So I count 1, 2, 3, 4, 5. I need to move my decimal point 5 times to the right to have one non-zero digit to the left of my decimal point. I can use this to write my number in scientific notation. 2 and 456 thousandths times 10 to the power of a negative 5. And I know it's going to be a negative exponent because my number was less than 1. This signifies that the exponent must be negative. So to summarize, I can only have one non-zero digit to the left of my decimal point. I need to move my decimal point to the left or to the right to get that done.
Now, if I start off with a number that's greater than 1, I will end up with a positive exponent for my 10. If I start off with a number that was less than 1, I'm going to end up with a negative exponent to my 10.
Now let's go over the process of converting numbers from scientific notation. Look at the value of the exponent on the 10. This is how many places you will move the decimal point. If the exponent on the 10 is positive, then the original number was greater than 1. Move the decimal point to the right that many places. If the exponent on the 10 is negative, the original number was less than 1. Move the decimal point to the left that many places. Again, if you have a positive exponent, that means that you want a final number that's greater than 1. So you need to move your decimal point to the right to make it a greater number. If the exponent is negative, that means that you want a final number that is less than 1. So that means you need to move your decimal to the left to make our final number less than 1.
Now let's look at some examples. First example says to convert 2 and 45/100ths times 10 to the power of negative 5 from scientific notation. My first step would be to write down my number, 2 and 45/100ths. Now, I see that I have an exponent that is a negative. This means that my final answer needs to be a number less than 1. So logically, if I need a number that is less than 1, do I need to move my decimal place to the right or to the left? I will move my decimal point to the left to end up with a number less than 1. Since the exponent is a negative 5, I'm going to move my decimal point over to the left 5 times. 1, 2, 3, 4, 5. Now what do I do with all the empty spots there? I'm going to put zeros. So my final answer is 0.0000245. So we converted 2 and 45/100ths times 10 to the power of negative 5 from scientific notation. So let's try the next example. If you would like to try this example out on your own, go ahead and pause the video now. Convert 1 and 67/100ths times 10 to the power of 8 from scientific notation. So I'm going to rewrite my number 1 and 67/100ths. I notice that my exponent is a positive. So that means I need to end up with a number that is greater than 1. So if I need a number greater than 1, which way should I move my decimal? To the left or to the right? Now, if we think about this logically, if I need a number greater than 1, I need to move my decimal over to the right. So let me count 8 times to the right. 1, 2, 3, 4, 5, 6, 7, 8. This is where my decimal should end up. What do I do with all these empty spaces? Well, I put zeros in each empty space. Wow, that's a big number. So when we convert 1 and 67/100ths times 10 to the power of 8 from scientific notation, we have 167 million